Good evening, ladies and gentlemen. My name is Ayman Baraka. I'm joined with Lindsay Collins, and this is our Project 9 in the Engineering 460.
Alright, so today we're going to talk about two main elements of our project. First, I'm going to talk about how we've created our new model based on the ants foraging model that we've spoken about in previous videos, and then I'm going to hand it to Ayman, who's going to talk about how what we've done can solve a subproblem and some applications for what we've done. So, as you can see on the screen is some of the Java code that we've been working with using Eclipse. And the first big change that we had to make to the ants foraging, obviously, was the verbiage that was being used, because everything had to do with ants and food and home and stuff like that. So obviously we wanted to change some of the words, as you can see here. We wanted to change it to resources, since we don't necessarily have food. We have natural minerals and resources like coal and copper and diamonds. We're using robots instead of ants. We're using sensors and signals rather than what's called pheromone in the ants foraging. So different things like that had to go through and be changed originally, just to kind of match what we were doing so we could have a better sense of the industry. The second major change that we had to make, and we'll go ahead and play this so you can see it. And as our model gets started, I'll just pause it real quick so we can talk through some of the changes. So the first change is we had to add some additional resources. And in the ants foraging, there was only one food place that the ants could go and get the food. But since we're doing a more upscale robot mining simulation, we wanted to have different places that they could go. So each of the four rectangular blocks that you see represent a different mineral. So the four that we've chosen for this simulation are diamond, gold, coal, and copper. And so each of those are represented here. And we also wanted to add 4 different bases. If you see in each of the corners, there's small dots, and that's where the robots start in the mine, where they start the tunnel outwards, as you can see, and where they have to return once they have their resources. So those were some big changes we had to make to the ants foraging model, since before there was only one home and one base, and now we wanted 4 of each. So we also wanted to change the number of agents that are being used. We only want 20, where before I think there was 50 ants, but since this is kind of a low, since this is a lower model, we wanted to just use 20 so we could see better what's happening. We wanted to change the pheromone. That's another thing that's different between the ants foraging and the robots mining. And the reason that this is different is because with the ants foraging, they're using the pheromone differently, and it was more visible, where we wanted this to be invisible because it's more like a signal and a sensor. We still want it to be used as kind of a GPS so that the agents can locate themselves based upon where the other robots are and where they're signaling. So if they know that somebody's got a signal to base 3, they can know where they are in proximity to that and find where they need to go. Also, we just changed the obstacles around a little bit. As you can see, we changed the color and kind of moved them to make an impact on our design. Also, we added values to the resources. Like I talked about before, there was only one food source, and obviously it doesn't matter what priority, because that's the only one they can go to, but obviously diamond is going to be more precious than copper, so there's different values going to each of these. And then some additional things that we're still working on. As we play the model, you can see it better. So we want to add cues. As you can see, what's happening is they start to follow the pheromone and go back and forth quickly, but what we think would be important for this is for certain things to take longer. Obviously, they're going to want to go toward diamonds, since they're going to get a better reward for that, and it's going to optimize our solution and the profits, but we want to create cues, so it might take longer to mine diamonds, even though it's going to be worth more in the end. So then we have more of a decision analysis and more of a systems engineering approach, where the robots need to decide, is it better to have to wait in this line for diamond, or is it better to go quickly and get gold or coal, or we won't have to wait in line. Also, another thing we want to change is the base capacity. For each of the bases, you can see, especially in the lower right-hand corner, what's going on is a lot of them are going back and forth to that base multiple times, but what we think would be important for the optimization is to create a limit, and we've been working on that, and we're almost complete with that, to create a limit where they can only bring so much food back to one base, and this adds another aspect of systems engineering where they're going to have to make a decision of which is going to be the next shortest path and what's the next route, since I can't necessarily go back to this base, where should I head from here? And then a final change that we'd like to make from the ants foraging is we want a more optimization approach. As you can see on the screen, this automatically stops after 2,000 steps. So basically, this is kind of like running a shift at work. So this is a shift of robots going into the mine, and obviously they're trying to optimize their profit and create the most money in the 2,000 steps or this shift. So how they do that is obviously getting the most precious metals in the greatest amount in the least amount of time. So they have to avoid the obstacles, also avoid the queues and worry about their distance and how long it's taking them to get different places depending on where they are. These are all things that have been changed in our robot mining and how we changed from the ants foraging. So I'm going to hand it over to Amen now to talk a little bit more about how this can solve a sub-problem.
Right. As she was talking about how our project has just some setbacks, but one thing we can talk about was how our project at hand can be used to solve a sub-problem, and those two sub-problems will be the routing problem and also the support structure problem. For the routing problem, our project at hand can be used to find the shortest path to get to the resources. And as she showed you with the model and the simulation, we saw that we have 3 different blocks to get to, and that can be divided to the diamond, gold, and copper, and all of that. And through that, the robots are trying to find what's the shortest path around the block and around to get to that resources that we want. And another thing, our project can be used to find resources that do not have a long queue, and that's one thing that we want to add to a project at hand is let's say if the diamond has a long queue, then the robot has to kind of like communicate with the others robot around to find what are the natural resources that need help. That means like say if diamonds has a long queue, then copper, the robot can choose to go to copper just so that they eliminate that time. And another thing is to optimizing, of course, the resources that is needed the most. And since we are all system engineering, it's all about finding the shortest path and also kind of like making an efficient process. So with the project at hand, we are always trying to find to optimizing the process, but also to optimizing the natural resources that is needed and that is at the mines. The project at hand can also be used to solve the support structure problem with our robots. They're communicating through sensors, and through that they can kind of organizing themselves where they need to be and where they need it, and how they can kind of carry the natural resources back at a home base. So this kind of like brings about the support structure problem solution, where using our project at hand, the robots in the mining can be used to solve the support structure problem solution. So those are 2 sub-problems that we found that our project at hand can be used to solve. So we thank you so much, and thank you for listening to us.